So whenever you have a function raised to a function, it's probably a good idea to use logarithmic differentiation. So use natural log and take natural log of both sides. Now the reason for doing that is because there's this rule from logarithms that says you can take this sign, bring it down in front and multiply. So that is not taking the derivative, that's just a rule from logarithms. Now we're ready to take the derivative. On the left side, the derivative of the natural log function is going to be 1 over y. And then you need to do the chain rule, take the derivative of y. On the right side, we need to do the product rule. So it'll be the derivative of sine is cosine, and then leave the natural log function alone. Plus, leave sine alone, and now take the derivative of this natural log, which will be 1 divided by whatever you find in the parentheses. And then we need to do the chain rule. Derivative of cosine is negative sine. All right, we're almost done, but there's a little bit more work we need to do. One is we need to solve for y prime. So it's going to be y times, and then this part can't be simplified, so just leave it as cosine of x times natural log of cosine of x. And then this part will be negative, and on the top it's going to have sine squared. And on the bottom it has cosine of x. Wait, don't turn off the video just yet, because we also need to replace this y with what it equals. So the final part is it's going to be cosine of x raised to the sine of x. And then recopy this part, cosine of x, the natural log of cosine of x, minus sine squared over cosine of x. That's sort of amazing to me. This little tiny function produces this big derivative right here. Didn't even know it had so much power, but it does.